Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day to all of you. Today we will discuss questions in order to identify whether the function is continuous or not by using limits. Okay, looks on question 6. Given fx in the piecewise function, you have three functions here, and then you are given limit x approaches to 1 equal to 4. So we know that when limit x approaches to 1 equal to 4 means that here limit x approaches to 1 from left for function fx equal to limit x approaches to 1 from right for function fx, which is equal to 4. So question A, find a value of a and b if a function fx is continuous at x equal to 1. So you want to find value of a and value of b. This one is continuous. So we know that when function is continuous, it must satisfy these three conditions. The first one, f1 is defined. Okay, and then number 2, limit x approaches to 1 for function fx is exists. And then number 3, f1 must be equal to the limit x approaches to 1 for function fx. Means that here number 1 should be equal to number 2. So for this case, we know that this function is continuous at x equal to 1, and then we want to find a value of a and b. So we can take, okay, for the limits, okay, limits x approaches to 1 from left. From left means that less than 1, which is this function, which is ax minus 1, and this one should be equal to 4. Why equal to 4? Because it's already mentioned that limits equal to 4 for x approaches to 1. So when we substitute 1 at x value here, we can get a minus 1 equal to 4, which is a equal to 5. Okay, so we can get the value of a. And then the other ones, limits x approaches to 1 from right. From right means that greater than 1, which is 3x plus b equal to 4. Why equal to 4? Because limit from left equal to limit from right, which is 4. So when we substitute x with 1 here, so we can get 3 plus b equal to 4. Okay, therefore b equal to 1. So that is the answer for question A, which is a equal to 5 and then b equal to 1. Now looks on question B. Okay, find the domain of fx. So in order to find the domain, we know that domain is a value of x. So we can see that from the first interval here, x less than 1, less than equal to 1 means that it start from the negative infinity until 1, and then this one including union. Start from 1 here, not including, until 4 including. So when including, we must put in the bracket like this, and then union start from 4 not including until positive infinity. If we can see that all the values are including, if you want to write it is something like this, is also correct, or we can write in the form of negative infinity until positive infinity. You can choose either one lah. Okay, that one for question B. Okay, now for question C. Okay, determine whether fx is continuous at x equal to 4. So you want to identify whether fx is continuous or not at x equal to 4. In order to check the continuity, you must fulfill all the three conditions. This one, okay, mesti. Okay, so question 1, you need to find what is f4. Okay, in order to find f4, we must see the function that have equal to sign on the 4 here, which is 3x plus b, x equal to 4 and b equal to 1. So you can get 13. Next, you must find limits, whether it exists or not. In order to determine limit exists or not, we must check from left and from right. So limit x approaches to 4 from left, which is less than 4, which is 3x plus 1 also equal to 13 when we substitute x with 4. Limit x approaches to 4 from right, which is x squared minus 5x plus 4 divided by x minus 4. If we substitute directly 4, we can get 0 divided by 0. Since 0 divided by 0, that is not the answer. We must factorize because it is involved in terms of polynomial function. So we need to factorize limit x approaches to 4 from right. So when we factorize this one, we can get x 4 1 minus x minus 4. So this one we can simplify. So when we substitute 4 here, so we can get 3. Okay, so here equal to 3. Okay, since the limit from left it is not equal to limit from right, we can conclude that limit x approaches to 4 for function fx does not exist. Okay, since limit does not exist, we can conclude that fx is not continuous at x equal to 4. Okay, so that is the answer lah. No need to write on the number 3 rules because the limit is already does not exist. Okay, now looks on question 7. For what value of k is the following function continuous at x equal to 0? So we want to check whether what is the value of k when a function is continuous at x equal to 0. Okay, so remember this one, x is not equal to 0, and then this one, x equal to 0. We know that if a function is continuous, means that here f0 must be equal to the limit x approaches to 0 for function fx. f0, this one, because x equal to 0, which is x plus k squared minus 4 equal to limit x approaches to 0, 2x plus sine kx divided by x. since we want to find limit x approaches to 0 and the function 0, so we need to substitute x with 0 here. So we can get k square minus 4 equal to this one. We can split into two parts. Okay, so we can get limit x approaches to 0, 2x over x plus sine kx over x. So this one we can simplify, equal to 2, and then the angle involve kx, so you need to times by k here, and then this one k. So this value we can get equal to 1. Okay, so k square minus 4 equal to 2 plus k. Okay, and then we can solve these equations. We can get k square minus k minus 6 equal to 0. All the value on the right hand side goes to the left hand side. Okay, and then factorize these equations. We can get 3 and 2 here, negative plus, which is k equal to negative 2 and 3. So that is answer for question 7. Okay, now looks on question 8. Given fx equal to 2x plus c for the x less than equal to 1, x greater than 1, the function is x squared plus 3. Find the value of c which make the function is continuous. So if the function are continuous, of course the limit is exists. When the limit is exists, we can check from left and from right must be equal, because it's only one unknowns. So we must have only one equation. So limit x approaches to 1 from left for function fx equal to limit x approaches to 1 from right for function fx. So limit x approaches to 1 from left, the function is 2x plus c equal to limit x approaches to 1 from right, the function is x squared plus 3. Okay, and then substitute 1 at x value, so you can get 2 plus c equal to 1 plus 3. So c equal to 4 minus 2, c equal to 2. Okay, so that is the answer for question 8. Now looks on question 9. Determine whether fx is continuous at x equal to 0 and x equal to 1. First, check for the x equal to 0. Means that here you must find f0 first. f0, the equal sign 0 here, so the function is this one, which is negative 0 square plus 3. So you can get 3. Okay, and number 2, you need to find limits whether it exists or not. In order to find limit exists or not, you must check from left and from right. So limit x approaches to 0 from left, the function is negative x squared plus 3. So substitute 0 at x value, you can get 3. Limit x approaches to 0 from right, the function is 2x plus 3, and then substitute 0 at x value here, you can get 3. Since from left equal to from right, we can conclude limit x approaches to 0 for function fx equal to 3. And then rule number 3, you should mention that function f0 equal to limit x approaches to 0 for function fx, which is equal to 3. Since it is satisfied these three conditions, number 1, number 2, and number 3, therefore we can conclude that fx is continuous at x equal to 0. So this is the answer for question 9a. Now looks on question 9b. You want to check whether fx is continuous or not at x equal to 1. So you must check f1 first. Okay. f1 must have equal sign here, which is 2 times 1 plus 3. So you can get 5 here. And then number 2, you must check limit x approaches to 1 from left, which is the function is 2x plus 3. So you can get here 5. Limit x approaches to 1 from right, the function is 6. So you can get 6. Since function limits from left is not equal to limit from right, so we can conclude that limit x approaches to 1 for function fx equal to does not exist. Okay, since the limit does not exist, no need to prove on the third condition. So automatically we can conclude that fx is not continuous at x equal to 1. Okay, so this is the answer for question 9b. Okay, now looks on question 10. Okay, find the value of c and d such that fx is continuous. So we know that when fx is continuous, it must satisfy the three conditions. So here we need two equations because we have two unknowns, which is c and d. Okay, so we can check f negative 3 equal to negative 1. Okay, so from here. And then we can check from limit x approaches to negative 3 from left. The function is 2x squared plus cx plus d. And then this one should be equal to negative 1 because when a function is continuous, limits also equal to the function. So when you substitute the value of negative 3 here, so we can get 18 minus 3c plus d equal to negative 1. So this is one equation. And then limit x approaches to negative 3 from right, which is the function is dx squared plus 5x plus c, and this one also equal to negative 1. When we substitute negative 3 at x value, we can get 9d minus 15 plus c, and this one equal to negative 1. So this one is equation 2. So we can solve simultaneously between equation 1 and equation 2 after you solve simultaneously, or we can use a substitution method. Okay, therefore you can get c equal to 185 divided by 28, and d you can get 23 over 28. So that is the answer for question 10. Okay, now looks on question 11. You have a piecewise function, and then also same thing, you want to find value of a and b so that fx is continuous everywhere. Since it's continuous, so it must satisfy all the three conditions of continuity. So we can check f2 equal to, we can choose this one because equal to 2a plus b, and then we can check limit x approaches to 2 from left, limit x approaches to 2 from left, which is x plus 3, and then this one we can get 5 after we substitute 2 here, and then limit x approaches to 2 from right, which is ax plus b. Okay, and then if we substitute 2 here, we can get 2a plus b. Okay, and then now we can check from x approaches to 3. Okay, this one for at x equal to 2, and then at x equal to 3, we can check f3. Okay, f3 equal to this one. Okay, so 3a plus b. Okay, and then limit x approaches to 3 from left, a function is ax plus b, so therefore this one equal to 3a plus b, and then limit x approaches to 3 from right, the function is 5x, which is 15. Okay, okay, so to solve this one, we know that we need to have two equations, which is this one is equal, left equal to right. So first equation, we have 2a plus b equal to 5, because it is continuous, limit from left equal to limit from right. And then this one also same thing, must be equal. Equation 2, 3a plus b equal to 15. Okay, and then we can solve simultaneously these two equations. You can get a equal to 10 and b equal to negative 15. So that is the answer for question number 11. Okay, now for question number 12, you have piecewise function, and then you want to find value of c, which make a function is continuous. So in order to find value of c, you have one unknowns only, so we can use the limits concept, which is limits from left equal to limit from right. So limit x approaches to 3 from left, the function is x plus c square equal to limit x approaches to 3 from right, the function is 5x plus c. Okay, so when we substitute 3 with x, we get 3 plus c square equal to 15 plus c. So expand on the left hand side, we can get 9 plus 6c plus c square equal to 15 plus c. So simplify this one, we can get c square plus 5c minus 6 equal to 0. This one we can get after you transfer all the item on the right hand side go to the left hand side. So we can factorize this one. Okay, we can get 6 1 plus negative, therefore c equal to negative 6 and 1. So this is the answer for question number 12. Okay, that's all. Thank you. Assalamualaikum.